Hi, the last video, what we did was to talk about the structure and the bonding that causes substances to be in solid state at RTP. And the last video, I talked about ionic compounds because they exist in giant lattice structure, and we went through all that. Now, today what I'm going to talk to you about will be why some solid state non-metals, okay, non-metallic, non-ionic substances actually also have high melting boiling points. Now, to focus on that, let's talk about the giant macromolecular structures of non-metals. All right, the ultimate examples that we have will be both allotropes of carbon, okay, diamond and graphite. Okay, both of them have the same kind of stuff that makes it very obviously solid at RTP. So, example, both of them are all made from non-metals. It doesn't really matter that it is all one type of atoms only, but they're generally all made from non-metals. So, both graphite and diamond are all covalently bonded substances, right? Of course, the first thing, the structure for both graphite and diamond are huge. Macromolecular. What does it mean, macromolecular? It means that the structure encompasses potentially infinite number of atoms, and they are all held together by strong covalent bonds, and for the most of it, there are no weak bonds inside that structure. So, let's talk about diamond. Diamond comes with a giant tetrahedral structure where every single carbon is bonded to 4 other carbons via strong covalent bonds. So the entire structure is extremely extensive, it's very well interlinked, and all the bonds are all strong covalent bonds. So obviously what we have to say is that therefore it takes a lot of heat to overcome every single covalent bond within the tetrahedral structure, and therefore diamonds will have high melting boiling point. And likewise, graphite, which is also another allotrope of carbon, they are not quite the same as diamond, but the same idea. They also come with macromolecular structure, but different. Okay, graphite has hexagonally arranged carbon atoms, and they exist in layers, okay, of carbon atoms all arranged in hexagons to each other. And in between the layers, there are some weak bonds. They are called van der Waals forces, but every bond within each layer are all strong covalent bonds. So there's no slouch down there. The structure of graphite is macromolecular, it's huge. The bonds that hold most of the carbon atoms together in graphite are all strong bonds, covalent bonds. And it's only the few in between the layers kind of weak intermolecular bonds like van der Waals forces that are weak in there. All right, now what about graphite? Graphite also has high melting boiling point because within each layer there are millions of carbon atoms there, and all of them are held together with strong covalent bonds. So again, the same idea. A lot of heat is required to overcome all these covalent bonds in order to release the carbon atoms and melt graphite. So that is the other thing about solid state materials that have macromolecular structure, okay? Diamond and graphite, completely covalent.